components, coplanar capacitors, interlayer thin insulator, low ohmic connectors, these are low ohmic connectors. Their capacitance top plate, bottom plate, E vector, top plate to bottom plate up to top plate T. After the top plate to bottom plate H, not stretchable. Overlap plus fringing capacitance, electrical permittivity F by M. Overlap fringing capacitance. C equal to M of, here I have to tell, this is multiplication with M, 1, L or W, this height. W or L here. This is A, this is B. So here in epsilon divided by H. H is the from top bottom to top plate to bottom plate. So this is the H. M is from here. Epsilon WL. This is L or W. We can consider now. This is W or L. Now consider this is W. L. 4 pi epsilon equal to electrical permittivity F divided M. This one. 4 by epsilon. Electrical permittivity F divided M. Width by L is width. Okay. This width. This L. Okay. Cannot consider a problem. This one length or width, or this one length and width. In there is logarithmic purpose. Ln of 1 plus 2h divided by t is h t h from top plate to bottom plate. We can say no, here also coming, so we can't be able to say this correct. So E vector vector. Then H T top plate distance. So yeah, 2H for this much T, 2 times H for this T, and then again here 2H, 2 times H for this T, and then multiply with the same, but plus add 2 here. Here what we are doing, then multiply with this both. After adding this, then multiply with this, then square rooting for scaling purpose. Then add with the again 2, then add with the 1. Then take logarithm ln. These both value divided by this. Divide for this. That is electrical permittivity F divided M. That is 4 times pi, 4 by epsilon. Then multiply with, after adding width and the length, then multiply. Okay, multiply these for this much. Then add with WL for multiplication, WL after WL multiplication, then epsilon divided by H for epsilon for this much H, this much. Then multiply with this, then add here. Then total value multiply with this M. Okay. Then only we find overlap fringing capacitance. Overlap fringing capacitance. Here, in this overlap fringing capacitance, sum of this total value here, but here CUA FM square process A process. This is dependent. So A plus B. This A from here, this B from here. Okay. Then typical available CMOS structures. Typical available CMOS structures. PIB already we know, polysilicon insulator poly or metal insulator metal. Okay. MOS metal oxide semiconductor greater than 1. Here 1 to 10 sandwich techniques, voltage linearity, temperature independent, CUA for process, F small f capital F divided by micrometer square. Typical available CMOS structures. Here, under this condition, that is here, voltage linearity for the MOS like this, for PIP or MM, polysilicon insulator, polysilicon or metal insulator metal like this, green. Temperature independent also green. But here, this process CUA, FF, small f capital F defined by micrometer square in MOS greater than 1. here in between 1 to 10. In mass voltage linearity not green, temperature independent not green. Here only independent, here only green, here only okay. For polysilicon insulator, polysilicon metal insulator metal, this is acceptable. Green for independent independent, temperature independent, and voltage linearity all are applicable. And then 1 to 10 sandwich techniques. This is sandwich techniques CUA FFM to a micrometer squares. Okay, this much FF. Okay, this much micrometers. So mass greater than 1 only, but here 1 to 10. Passive components. Here we have seen coplanar capacitors. Here serpentine resistors. Serpentine resistors. Here this is high resistive strips. These are high resistive strips. Low ohmic contacts. 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 Okay, like this. Low ohmic contacts. Here this length, this is the L length L. Here width W. Here also. This is here R. So this is high resistance. I told you here this is wrong left. This total capacitor. So we can consider like this only. Wrong capacitor total. Sorry, this is considered as capacitor. This total. Okay, this total are considered as capacitor. In this point of view, here we explain. Okay, here this total resistance. Okay, here not stretchable. This length here this much width, this width here. Okay, and then this width, this length. Okay, and then height and the yes, not stretchable, height, width, this much length, this total yes. Okay, here R resistance equal to N into L by S rho. This rho is the volume resistivity micrometer unit. Okay, so R equal to N into L by S. Okay, this N, this is N, this is S. Rho volume resistivity micrometer. This L length here we will have to mention. This N, this is this S value here, and after that we will find R square resistance. R equal to rho by H mu square resistance.